An angle theta has a terminal ray that falls in the third quadrant, and we're given what cosine of theta is. So I'm going to sketch what that would actually look like. So we know we're talking about the third quadrant. So that's going to be the bottom left. And we're going to make that into a right triangle with theta here. Now, like we were told, cosine theta is equal to -7 over 25. So remember, when we were thinking about TOA, we're thinking about adjacent over hypotenuse. So the adjacent would be here, which checks out that that's a -7, and the hypotenuse would be 25. Now what we want to look more at is that we're trying to figure out the value of sine theta. So that's my opposite over my hypotenuse. But unfortunately, we don't have the opposite. So we don't have the side that doesn't touch the angle. When you're missing that piece, we can solve for any missing side of a right triangle using Pythagorean theorem. So we would set it up as x squared plus 7 squared equals 25 squared. And if you solve through that here, we would get x squared plus 49 equals 625. We'll end up with x squared equal to 576, and x equals 24. Now that I found that missing side, the last piece we need is for sine of theta to equal the opposite, 24 over 25. But keep in mind, sine is negative in the third quadrant, so we'd have to have a negative, because remember, A, S, T, C, sine would be positive in